It's no secret that Boeing Starliner doesn't exactly have a good track record when it comes to flights to the ISS. Due to the various issues faced by the spacecraft, astronauts from the last crewed flight test have now spent 50 days on what was expected to be a one-week mission to the ISS. Now, engineers from both companies are scrambling for answers that could solve the issues and save the astronauts. However, answers are not forthcoming and time is running out. What then is Boeing and NASA's next step, and what would be the fate of the astronauts? Before we get into all of that, I would like to welcome you to the Space Minds channel. Here we uncover space mysteries and take you on exciting adventures. If you're a fan of rockets, galaxies, and other space-related stuff, you're in the right place. So hit that subscribe button and join us on this intergalactic adventure. Also, don't forget to ring the bell so you can get notified every time we post. Now, how did Starliner get to this point of needing help from the SpaceX Dragon? Since its first orbital flight test, the Starliner has had various issues. However, the recent crewed flight test showed that these issues might be deeper than we thought. The company had to cancel the launch twice before this date due to concerns surrounding the Starliner's oxygen valve, helium leaks, and thruster failures. Eventually, they launched on June 5, 2024, with a crew of 2 NASA astronauts, Barry Wilmore and Sunita Williams. During this flight, Starliner experienced even more helium leaks, and by the time it reached the ISS, 5 of its 28 thrusters had failed. They had to reset and fire these thrusters again to make it to their destination. Eventually, they got 4 out of the 5 thrusters working again and made it safely to the ISS. Unfortunately, as a result of challenges with the rocket, what was supposed to be a week-long mission has been extended to over 50 days. Many even say that the astronauts are stuck in space with no hope of returning before the 90-day docking time is up. However, NASA and Boeing have debunked these rumors, stating that both astronauts are fine with emergency means of returning to Earth when needed. They also stated that the delay was merely due to thruster failures and helium leaks during the journey. Of course, the recurring issues of thruster failure and helium leaks have made it clear to Boeing that it wouldn't be safe for the astronauts to return to space without finding the cause of these issues. On this matter, Mark Nappy, Boeing's commercial crew program manager, commented that further tests would help finally understand the cause of these issues. One such test was conducted in New Mexico, where engineers fired test engines over 1,000 times to replicate how the thrusters on the space-bound Starliner would ignite. They've also tested various scenarios to understand better how the engines might operate when returning from space. The primary goal is to gain more insights into the possible challenges or dangers that might occur when the thrusters are fired again. Boeing and NASA officials revealed that they were able to recreate the thruster deterioration experience during the flight. This allowed them to discover that heat buildup inside the thrusters may be causing Teflon seals to bulge, thereby restricting the flow of nitrogen tetroxide propellant. Let's break that down a bit. Usually, there's a poppet valve similar to an inflation valve on a tire, designed to open and close to control the flow of propellants. This poppet has a Teflon seal at the end of it, and through the heating and natural vacuum that occurs with the thruster firing, that poppet seal became deformed and the Teflon seal bulged. But what could be causing these thruster overheating problems? Engineers were able to link this to 2 main causes: sunlight and the thermos effect of the entire doghouse. So the rear-facing thrusters are exposed to more sunlight as Starliner orbits the Earth. On top of that, there are 7 thrusters in each doghouse of the spacecraft. Since each thruster generates heat, there was sure to be a ripple thermos effect with the combination of heat coming from 7 thrusters. This eventually led to the thruster degradation. So what approach did Boeing and NASA officials take to solve this problem? Generally, the thrusters aren't needed while the Starliner is attached to the space station. So the major focus is whether the seal could survive the undocking and deorbit burn of the Starliner spacecraft. The team tested this by firing the thruster on the ground 5 times more than it would need for the Starliner to return to Earth. Thankfully, the seal remained intact. This has made NASA and Boeing more confident in the Starliner's capabilities. However, according to NAPI, the downside is that this test also made it clear that they might have to reconsider their plan for the astronauts to fly the Starliner spacecraft manually on the return mission. Steve Stitch, NASA's Commercial Crew Program Manager, explained that manual maneuvering would cause additional strain on the thrusters, which might not be safe for the return journey in the long haul. Now, to the helium leaks. Engineers have conducted various tests on the vehicle in space while it remains docked at the ISS. They've also fired 27 of the Starliner thrusters to gather more data. Ground analysis of a Starliner service module that has been sitting in White Sands, New Mexico for about 3 years also showed that helium leaks may be due to seals degraded by exposure to propellant vapor. To fix this, NAPI mentioned that the best course of action might be to replace the seals with a material less susceptible to degradation. According to him, this could alter and improve the status of future Starliner missions. As much as Boeing and NASA are interested in finding out the causes of the helium leaks and thruster failures, their top priority is the safe return of the astronauts. This means they have had to make a list of contingency plans. Even NASA has admitted that if things go south, they might have to call in the SpaceX Dragon to help. They've also considered other backup options like using other capsules to get the astronauts back home safely. SpaceX has one Crew Dragon currently docked at the station and another slated to launch with a fresh crew in August. Considering this, Stitch mentioned that the rescue plan for the astronauts would be similar to the one originally developed for the MS-22 mission to rescue NASA astronaut Frank Rubio and his team when the Soyuz spacecraft developed a coolant leak. The rescue plan for the NASA astronauts was to bring them on a SpaceX Crew Dragon capsule, if necessary. Although the astronauts were later rescued using a different method, now that Boeing finds itself in a similar situation, it is considering the same rescue plan. The only difference is that these plans would be modified to suit Starliner's peculiarities. Although rescuing the astronauts using SpaceX's Starship is one of the options considered, Stitch still made it clear that the Starliner is the primary option for bringing the astronauts home. They just want to understand the thrusters a bit more to prevent future issues. So what makes the SpaceX Crew Dragon different from the Starliner, and why is it an option that Boeing is seriously considering to save the NASA astronauts currently in space? Well, I guess we'll find out in a bit. First, both the SpaceX Crew Dragon and the Starliner are composed of a reusable capsule and an integrated trunk designed for missions to low Earth orbit and beyond. While the SpaceX Crew Dragon capsule is slightly smaller than Boeing's Starliner, it can hold a crew of up to 7 people and remain docked on the ISS for up to 7 months, just like the Starliner. This makes it a perfect alternative to completing a mission that has been failed by the Starliner, but that's not even the best part. Another difference is that the Starliner features a traditional cockpit with physical buttons and switches, making its interface similar to that of legacy spacecrafts, while the cockpit of the SpaceX Crew Dragon has modern touchscreens and few physical controls, looking more modern and minimalistic. Now, here comes the shocker. The major difference that makes the SpaceX Crew Dragon a very viable alternative is that, unlike the Starliner, it has already undergone both uncrewed and crewed flights. Yes, the SpaceX Crew Dragon has experience and credibility, and it has already carried 8 NASA crews and 3 private crews to the International Space Station. Now that we know what makes the SpaceX Crew Dragon a viable alternative for Boeing, what exactly does this mean for them? Well, if Boeing and NASA insist on using Starliner as their primary option, they'll have to make sure their solutions are airtight. Apart from changing the seal materials, Boeing and its propulsion supplier, Aerojet Rocketdyne, may need to modify the thruster design. To address the thermo effect of the heat buildup, they might also have to change the insulation of the doghouses or make a few software adjustments to fire the thrusters less often. But Starliner has been having these issues for a long time. and they still haven't found the best solution. Will they be able to find one in time, or will they eventually have to enlist the help of SpaceX's Dragon? I guess only time will tell. Boeing Starliner might be experiencing some issues, but the test results seem like everything will be just fine in the end. And if it doesn't work out, at least they have the option of turning to SpaceX Dragon for rescue. So that's all for today. If you enjoyed this video, make sure to hit that like button, share it with your friends, and subscribe to Space Minds for all the latest space news and updates.